lift acceleration related to friction. We have example 1. Two bodies, x and y, of masses 5.0 kilogram and 7.5 kg respectively are connected by a light inextensible string as illustrated in the diagram above. Look at the light inextensible string passing through a pulley, the groove of the pulley, and connecting the mass x. Are we there? If x is placed on a rough surface, this x is placed on this rough surface, this is surface, rough surface, of coefficient of friction 0.5. They ask us to calculate the magnitude of 1, the normal reaction on x, the normal reaction on x, II, the frictional force between x and the surface, and lastly III, the tension in the string. Now let's look at this problem together. Now one, they ask us for the normal reaction. Now we have normal reaction is equal to what? Mass times acceleration due to gravity. Now the mass of this x is what? 5 kg times what? Acceleration due to gravity is 10 meters per second square. So I will multiply that by 10, which will give me 50 Newton. Quite easy, right? Now let's see. They ask us for the frictional force, F. We know that from our past lessons, we know that frictional force is equal to what? Mu Rn. That's mu times the normal reaction. And what is our mu? Mu is the coefficient of friction, which has been given to us as 0.5. So I'm going to multiply 0.5 times the normal reaction, which is 50. Alright? Now that gives us 0.5 times 50 gives me what? 25 Newton. Quite easy, right? So we'll go to number 3, IIR. They said the tension in the string. Are we there? We know that the tension on this string will be pushing towards the right. So I'll have T minus the frictional force, which is mu Rn, is equal to the mass of x is equal to mx times the acceleration of the string. Are we there? Okay? Now if we call that equation number 1, let's see. Let's look at the second mass, which is the weight of this will be pulling downwards. So I'll have W, Y, right? Minus the tension going upwards, minus T is equal to the mass of Y, which is N, Y, right? Times what? Acceleration due to gravity. Now we call that equation number 2. Are we there? Let's input the values. Now from equation 1 we have T minus, what is the coefficient of friction? 0.5. 0.5 times the normal reaction. What's the normal reaction? 50. Is equal to the mass of x. Mass of x is 5 times acceleration, which is A. Let me call that one equation number 1. Are we there? Now, the weight of the 7.5 kg will be what? 75 Newton. All right? 75, right? Minus our tension T is equal to the mass of this 7.5 kg, which is 7.5 A, right? Call this one equation number 2. Now let's see. From equation 1 we have T, right? 0.5 times 50 will give me minus 25. Are we there? Is equals to what? Is equals to 5A. Are we together? Okay? Now, if I take 25 to this side, I'll be having T is equals to 5A plus what? Plus 25. It's minus 25 here. When I take it to the right hand side, it becomes plus 25. I call that my new equation 1. Are we there? Now look at equation 2. If I T is minus here, if I take it from the left hand side to the right hand side, it becomes positive. I'll have T, okay? Then I'll bring the 7.5 from the right hand side to come and meet 75. I'll have T is equals to 75 minus 7.5A. I call this one equation number 2. Now look up. From equation 1, we have T is equals to 5A plus 25. And from equation 2, we have T is equals to 75 minus 7.5A. Alright? Now if T is equals to this, T is also equals to this equation. Invariably, this equation is equals to this equation. I'm going to use that. 5A plus 25 is equals to 75 minus 7.5A. Are we together? Now let's bring the like terms together. Sorry. I'm going to take this minus 7.5A, bring it towards the left hand side. I'll be having 5A plus 7.5A is equals to what? I'll take this plus 25 to the right hand side. It will become 75 minus 25. 75 minus 25. Are we there? So we have 5A plus 7.5A. That will give me 12.5A. 12.5A is equals to 75 minus 25 will give me 50. Alright? So if I divide by 12.5 on both sides, I will have my A is equal to what? 4 meters per second square. 4 meters per second square. Now they asked us, find the tension in the string, but we'll be able to obtain the acceleration of the string. We can apply the acceleration on any of these equations, equation 1 or equation 2. Now let us choose to apply the acceleration on equation 1 so that we'll be able to get the tension. So I would say T, the tension T on equation 1, T is equals to 5 times the acceleration. What's the acceleration? 4. Are we there? Are we there? Plus what? Plus 25. Plus 25. What is my T? T is equals to 5 times 4 gives me 20. Are we there? Plus 25. That will give me the tension as equals to 45 Newton. Quite easy. Is that right? We take the next example. Find the acceleration and tension of the system shown above. Now we have a pulley, and then we have a string passing across the groove of the pulley, holding one body of mass 20 kg, and then the other body of mass 30 kg, the incline is at 30 degrees. We are asked to find the tension, right? Tension T of the system of forces. Now, if I look at this, the tension here T is going towards the right. So I can say T minus mg sin theta, the frictional force going downwards. Mg sin theta, right? Is equals to what? Is equals to this mass of 20 kilogram times the common acceleration. Alright? And let us look at equation number 2. Now have this weight W, are we there? Minus the tension T is equals to what? The mass of 30 kilogram M30 times the common acceleration. Are we there? Now let us slot in the values. From the first equation, T minus 20 times 10 will give me 200, right? 200 sine 30 degrees. Sine 30 degrees is 0.5, right? Times 0.5 is equal to N20, which is what? 20A. Are we there? Alright? Let me see. T minus 0.5 times 200 will be 100. Is equal to 20A. Let me call this one equation number 1. Let us look at equation number 2. Now we have W, which is the weight of this 30. W is 30 times 10 will give me 300. Are we there? Minus the tension is equal to mass of 30 what? Times the common acceleration. Are we there? Let us call this one equation number 2, II. We can rearrange both equations, alright, and make T the subject of both equations. Now from equation 1, I can say T is equal to 20A plus what? Plus 100. Are we there? Call this equation number 1. Now let's take this T to the other side. Our T is equal to what? 300 minus 30A. 300 minus 30A. Let's call this one equation number 2. Now, from equation 1, we have T is equal to 20A plus 100. From equation 2, we have T is equal to 300 minus 30A. Now, therefore, T is equal to T. So I will say 20A, I will say 20A plus 100 is equal to 300 minus 30A. Let's see. So can I bring this to this side and take 100 to this side? I will have 20A plus 30A is equal to 300 minus 100. Now 20A plus 30A will give me 50A is equal to 300 minus 100 will give me 200. Are we there? Therefore, A is equal to 200 minus divided by 50. Alright? Cancel out. A is equal to what? 4 meters per second squared. Quite easy. Are we there? Now they ask us for the tension, right? Tension T. So I can choose from any of these equations, right? And find my T. I can choose equation 1 or I can choose equation 2. Let us just choose equation 1. Equation 1 says T is equal to 20A plus what? Plus 100. Plus 100. Right. Therefore, T is equal to 20 multiply. What is A? A is 4. Multiplied by 4 plus 100. So T is equal to what? 4 times 0, 0. 2 times 4, 8. 80 plus 100. So our tension equals to 180 Newton. That was quite easy enough. Are we here? Example on linked acceleration related to friction. Now the question is, a light inextensible string passes over a smooth pulley, all right? That's the pulley, and carries masses of 4 kilograms, right? And 3 kilograms at its end. That's the string now, right? These are the masses, 4 kilograms and 3 kilograms. The masses are released. Now, if we place our finger here and then we release our finger, the mass of 4 kilograms will likely pull down while the 3 kilograms goes up. The masses are released from rest. Find one, their common acceleration. I, their speed after 2 seconds. I, the distance traveled at the time. And then you are asked to take your G as 10 meters per second square. Now we will consider this mass, 4 kilograms, is the heavier mass, all right? Now the weight of the 4 kilograms will pull down. Now if I write W, all right, 4 will pull down, all right? Now the tension pulls up minus T is equals to the mass of this 4 kilograms is equals to N4 times acceleration, right? Let me call this equation number 1. Are we there? Now let's look at the 3 kilogram mass, right? Now I will have T, which is the tension, right? Minus the weight of this 3 kilograms minus W3 is equals to the mass of this 3 kilograms M3 times the acceleration. Let's call this equation number 2, II. Are we there? What is the weight of this 4 kilograms? That's 4 times 10. That will be 40. All right? 40 minus T is equals to the mass of this 4 kilograms, 4 times acceleration. That's equation 1. Now, let's look at equation 2. We have T minus the weight of this 3 kilograms. That's 3 times 10. That would be 30. Is equals to 3A. Equation number 2. Right? What do we do? Let's consider equation 1. Let's take this T to the right hand side. I will have T equals to what? 40 minus 4A. Right? Now let's look at equation 2. Let's leave T on this side. That means I'm going to take this minus 30 to this side. So I will be having from equation 2, T is equals to 3A plus what? Plus 30. Call this one equation, our new equation 2. We have from equation 1, T is equals to 40 minus 4A. And we have from equation 2, T is equals to 3A plus 30. T is equals to this, T is equals to this. That means invariably this equation is equals to this equation. So I'm going to put 40 minus 4A is equals to 3A plus 30. Are we there? Correct, right? Now, let us bring this 30, the last terms together, right? So I will be having 40 minus, it's plus here. Once it crosses the sign of equality, it becomes minus 30 is equals to what? Now 3A is here. Now minus 4A on the left hand side. If I bring it to the right hand side, it becomes plus 4A, right? Plus 4A, all right? 40 minus 30 gives me what? 10 is equals to 3A plus 4A gives me what? 7A. So when you divide both sides by 7, I'll have A is equals to what? 10 all over 7. Are we there? Okay? Now, we have in meters per second square. I could divide it out and I will obtain, let's see, 1.43 is equals to 1.43 meters per second squared. That's acceleration. That's if I divide 10 by 7. Now we are done with 1, the common acceleration. Now their speed after 2 seconds. Now mark you, the question said the acceleration, we've gotten it as a is equals to 1.43 meters per second. All right? And they said the body is released from rest. That is u is equals to 0. What else do we know? We know that the time is what? 2 seconds. Their speed after 2 seconds. Now, t is equals to 2 seconds. Now we have 1, 2, 3, right? So we can apply the equation of motion. Now we apply first equation, v is equals to u plus what? At. Are we there? Are we together? So we have v is equals to, what's the initial velocity? 0. Right? What's the acceleration? 1.43 times what? The time, which is 2 seconds. What is our velocity, final velocity? That will give us 2.86. 2.86 meters per second. Now we said their speed after 2 seconds. The speed after 2 seconds will be 2.86 meters